So we're now in the third part of polymorphism, and this is dynamic or late binding and static or early binding. And these can be fairly complex, so you need to pay close attention to this. We're going to start off by looking at the static or early binding. Essentially what this means is that if you have two variables in both the base class and the subclass with the exact same name, the program will know which one to use at compile time. So, which is usually, or which is always, the base class version. So you got to be careful about this. So this is another reason why we use accessors and modifiers. So if you want to make sure you're using the subclass, you got to make sure you have an accessor, so we'll access the appropriate value for that. So looking at the example that we were looking at a few minutes ago, we can see that right here under the program we have created two persons, both of them parents, but one of them is a parent, one of them is created as a child. This is setting up the polymorphism. So I've created a person 2 that is of type parent, but it's been instantiated as a child. So this is going to tell it to use the polymorphic abilities. So how do we actually implement this? Well, essentially when it does this, it calls the constructor of the child, but it's still a parent, but more specifically a child. So when we're looking at this, we've created our parents, and a parent just has a default constructor with giving it a name. The child also has a default constructor giving it a different name, Peach. They both have a display name subprogram. The display name inside the subclass is overriding the virtual version of the same subprogram in the base class. So we should get the proper functionality when we expect it. Now, we want to look at static or early binding. And to do that, we need to look at this right here. This is a variable that is created in both the parent as well as the child. Now the thing is, when C# compiles this code, it knows that it's going to always use the base class version of this data. So if we're looking at this and we see this command right here, these two output lines, my name is person1.name, my name is person2.name. Because these are both parents as a base class, it's always going to output the value of name from the base class. Looking at this, the value of name in the base class is always Frank. So when we run the program, the first two lines of output we should see in the program should be my name is Frank. Just let's show this. And that's exactly what we see. My name is Frank twice. So of course this isn't always what we want. We got to make sure that we get the data that we expect. Normally you're not going to try and output the base class. So how are you actually going to fix that? Well, that's why we use our accessors and modifiers. Again, the base class has a subprogram called display name, and it's going to say I'm the parent and my name is name, and it's going to use the name from this class. This is a virtual subprogram. In child, we overrode that subprogram, and we now overrode it to say, let's comment out this base class version so we don't actually get that. It's going to say I am the child and my name is, and it's going to get the name from this class, not the base class. So it beats out that static binding. So we look at this ability of beating out that static binding is what we call dynamic or late binding. So dynamic or late binding is when a programmer calls a subprogram that is overridden. The program knows at runtime which version to use based on what type of object it was instantiated as. So for example, when we look at that code inside of the basic program, person1 was instantiated as a parent. So whenever we call display name, it's going to use the parent version. Person2 was instantiated as a child. So whenever we call display name on person2, it's going to use the child version. That's why when we run this program, we're going to get the appropriate I am a parent for person1 and I am a child for person2. So those should be our output lines 3 and 4. So when we run our program again, we get I am a parent and my name is Frank, and we get the next line, I am the child and my name is Peach, even though they're accessing the name value. So we look at this. So variables are static or early bound, so it always knows which one to use, the base class version. Overridden functionality is dynamic or late bound, so it's always going to use the appropriate subprogram. This is the real power of polymorphism, is the ability for it to use the appropriate one at the appropriate time. And that's what it means to be dynamic or static bound. One other little feature I wanted to show you was sometimes if you're creating certain information and you're not sure what type it is, let's say for example it's a child or parent, because you might have a list of parents, which some might be child and some might be parent. So you may need to go through and check to see what type it is. So this little if statement here does exactly that, using this keyword is. Is checks its object type, what type it was instantiated as. So person 2, we can say if person 2 is a child, then it will output this line. Otherwise, if person 2 is a parent, it will output this line. Now we know for a fact, looking at the code up here, that person 2 is a child. We go down here, so it should only go in this if statement. So we should get person 2 is a child as output. So if we run our program, we get person 2 is a child. Of course, if we went back up to the top and we changed this from child to parent, and we ran the program again, we now get that it's a parent. And we also get that previous line changed from Peach to Frank, because we changed the way it was instantiated. Let's go back and fix that the way it was. And then finally, the last output of this demonstration is using the overloaded functionality from the parent class. Person1.writeStuff, hello. Person1.writeStuff, hello, and world. And if you remember, the functionality essentially just split it up. The first implementation of writeStuff just output it on one line. The second implementation took each piece and output it on a separate line. So again, if we run our program, we get hello for the first output, and then we get hello and world on the next two lines for the second output, calling the overloaded functionality. Now if we look at this, if I try and type in person2 dot write stuff, you can see that it still exists. We have both implementations of it. We still have access to it, even though person2 is a child and not a parent. Just get rid of this stuff. And we look at this. That is because this data is public. It would have also worked if these access modifiers were protected as well. The problem was if we made these protected, then program wouldn't have access to them. So it wouldn't be able to see them from here. Okay, so that is polymorphism in a nutshell.